In this video, we will cover some of the features of Sparkflows Fire Insights on Google Cloud. If your data is not already on Google Cloud, Sparkflows provides a variety of data migration tools. Sparkflows can connect to a variety of both legacy and modern data platforms, and can also ingest a multitude of file types, both structured and unstructured, to bring in data in any condition. Data is then stored in GCP or BigQuery for optimal performance. Now we will go into a demo of a Sparkflows machine hosted on Google Cloud. First, let's start with the Administration tab. This is where we can set up our users, their groups, and their roles for proper control over what they can access. Next, we will go into our connections, or global connections. Here we can see we have one connection with the name DataProc. With this connection, we can also edit the details and configure various factors, such as the file core jar and the cluster name, along with the main class. Next, in the Administration tab, we will look at the configurations. This is where we can see our GCP configuration, and we can also edit some of the fields here. Finally, we also have our Git connection and configuration here. We can also connect to our Git repositories for proper version control. Now we'll go into a demo of a Sparkflows project based on a retail ETL workflows. Here in the workflows, we first have our data connections and our data ingest workflow. This is where we are bringing in various files from various places and combining them to create one file, which we will then send to BigQuery for further analysis. We can bring in various types of files. If we look under the data connectors here, we can see all of the different types of databases that we can connect to and different file types which we can read from, which we can then combine into one single space using Sparkflows with no code. Next, let's take a look at an example of unstructured data being taken into Sparkflows. First, we have our transaction JSON and our cancellations JSONs here. We can see that in their current state, these files are not particularly useful, and we cannot conduct further analysis on them. However, using Sparkflows with no code, we can use various functions such as the flatten and explode functions to then turn these into usable files, with our final output being ready for further analysis, now in a more structured format and a more usable format. Next, let's take a look at data validation and data quality checks. Here in Sparkflows, we have data validation along with great expectations, which allows us to do more complex data quality checks. In this workflow, we have an example of various data quality checks using great expectations. In each of these nodes, we can configure our data quality checks with no code. Then we can view the output results of this data quality information in a single pane under our data quality tab here. This is where we can see the status of all of our checks in one place for incoming workflows, so that we can ensure that any ingested workflows meet our requirements before we move any further. Next, let's take a look at the actual ETL or some feature engineering. Here in this workflow, we are calculating various features such as extracting fields from the date and the time, which can all be done with no code. Then again, we are writing to BigQuery for further analysis. Another cool feature of Sparkflows is the ability to generate PySpark code. Here we can generate open source PySpark code from our workflows without writing any of the code ourselves. We can either copy it or download it for future use. Finally, we need to take our BigQuery data and we need to conduct some analytics on it. To do this, we can also read from BigQuery, write from a workflow, and then conduct our analysis, where then we will be able to see some of the charts and tabs and build them into reports and dashboards. Now that we have completed our ETL and our data analysis, we can also create pipelines here, all within Sparkflows and all within the same project. Here in a pipeline, this allows us to orchestrate our workflows, to determine the order of our workflows, and to create a single pipeline which will run and command all of the workflows within a project. From workflows, we can also schedule our workflows. Here, when we create a schedule, we can specify our Spark Submit options, our connections, such as to our Dataproc clusters, and alerts using the email on success, email on failure. We can configure these to start and end at a particular day, along with their frequency. This concludes our demo of an ETL project on Sparkflows, hosted on a Google Cloud. Thank you for listening.